Nvidia just spent billions designing chips around a problem that China may have quietly solved with a rock you can buy at a jewelry store. Before you keep watching, drop a comment right now with just one word. Silicon if you think nothing beats it, or diamond if you think China just changed the game. I read every single one. And I want to see this debate in the comments. And hit subscribe before we go further, because this channel breaks down China's tech moves before the mainstream even notices them, and trust me, this one is going to blow up. Here's the sentence that should not make sense. The most advanced AI chips on Earth, the ones that cost tens of thousands of dollars each, are being threatened not by a rival processor, not by an export ban, not by a smarter competitor. They're being threatened by heat, pure, simple, physical heat, and the material that might solve it isn't some exotic lab-grown super element nobody's heard of. It's diamond. The same diamond sitting in engagement rings, except the diamond at the center of this story isn't mined from the ground. It's grown on purpose in Chinese factories by the millions of carats in China just figured out how to put it directly onto a chip. Let's get into why that's such a massive problem for Nvidia, and why this story is bigger than one chip. To understand why this matters, you need to understand the wall the entire chip industry just slammed into. For 50 years, the chip race was about one thing: cramming more transistors into a smaller space. Smaller transistors, more power, that was the whole game. Nobody talked much about heat because it wasn't the bottleneck. It is now. Today's most advanced AI processors are blowing past 1,000 watts of thermal design power. Some of the newest semiconductor designs are generating heat at densities over 500 watts per square centimeter. To put that in perspective, that's hotter per square inch than the nozzle of a rocket engine. And there's a brutal rule in the chip world called the 10-degree rule. For every 10 degrees Celsius a chip heats up beyond its target, it loses 3 to 5% of its performance, and its lifespan gets cut in half. So the fastest chip in the world is useless if it can't keep itself cool enough to actually run at full speed. For years, the industry's answer was copper. Copper heat sinks, copper vapor chambers, more fans, more liquid cooling loops. It worked sort of the way patching a leaking dam with sandbags works, but copper has a ceiling. Its thermal conductivity is good, not great, and as chips get hotter and denser, copper increasingly can't move the heat away fast enough. Engineers needed something dramatically better. And that's where this story gets strange, because the best heat conductor known to science was sitting in plain sight the entire time. Diamond. Here's the number that should stop you cold. Diamond's thermal conductivity is roughly 5 times higher than copper, and about 13 times higher than silicon itself. It moves heat away from a hotspot faster than almost any material humans have ever measured. And it's not just about raw speed. Diamond's thermal expansion behaves almost identically to silicon, which means as a chip heats and cools, the diamond layer doesn't warp or crack against it the way other materials do. On top of that, diamond is actually an electrical insulator. That means it can sit directly on top of a chip's hottest components without causing a short circuit, no thermal paste, no extra insulating layer needed. It's almost suspiciously perfect for this job. So why hasn't the world been using diamond on chips for decades if it's this good? Because making diamond thin, smooth, and cheap enough to mass produce on a chip was, until very recently, basically impossible. Diamond is famously the hardest natural material on Earth. Cutting it, shaping it, and depositing it as an ultra-thin film without cracks or defects required a manufacturing breakthrough nobody had cracked. And that breakthrough is exactly what just happened in China. In late 2024, researchers from Peking University, the Southern University of Science and Technology, and the University of Hong Kong published a breakthrough in the journal Nature. They developed a method to grow diamond film that was ultra-thin, smooth, and economical enough for industrial-scale use, solving the exact manufacturing bottleneck that had kept diamond out of mainstream chip production for years. Around the same time, Huawei partnered with Xiamen University on integrated diamond heat dissipation technology for advanced chip packaging. Their results were measurable. In tests, a diamond-integrated heat dissipation layer cut the maximum junction temperature of a chip hotspot by over 24 degrees Celsius and reduced the chip's overall thermal resistance by nearly 29%. That's not a marginal improvement. Remember the 10-degree rule. 24 degrees of cooling headroom could mean the difference between a chip throttling itself and a chip running flat out, and here's the part that should genuinely concern Nvidia and the rest of the West. China doesn't just have the science, it has the supply chain already built. China produces somewhere between 70 and 95% of the entire world's synthetic diamond supply, depending on the grade. This isn't a new industry China is racing to catch up, and it's one it already dominates, the way Saudi Arabia dominates oil. China's synthetic diamond sector alone generated more than 17 billion yuan in output value in 2025. Multiple publicly listed Chinese companies names like Lingyi Diamond, Zhongbing Hongjian, and Huang Whirlwind are now explicitly pivoting towards semiconductor-grade diamond products alongside specialized firms, developing diamond heat sinks specifically built for chip packaging. This is the same pattern we've seen over and over with China's chip strategy. When the West controls the front door advanced lithography, GPU exports, China finds the side door nobody was guarding. This time that side door is cooling. And the market clearly sees where this is going. Diamond thermal solutions for chips are currently a tiny market worth around $50 million globally. Analysts project that number could explode to over $15 billion by 2030. That's not gradual growth. That's an industry being born in real time. Even American companies are paying attention. A U.S. startup called Cash System secured government funding specifically to develop diamond-cooled GPU technology, recognizing the same thermal wall everyone else is hitting. But here's the uncomfortable twist, because China controls roughly 70% of global synthetic diamond production. Even Western diamond cooling efforts may end up depending, at some point in the supply chain, on Chinese-made material. The wall America built around advanced chips never accounted for the cooling layer underneath them. Nobody was watching it, until now. Now, let me be completely honest with you, because a hype video would stop right here and call it a done deal. It isn't. Diamond-cooled chips at true mass market scale are still in early industrialization, not full deployment. Most of what we're seeing right now is breakthrough research, pilot programs, and early commercial partnerships, not yet diamond heat spreaders sitting inside every data center on Earth. Manufacturing diamond film at the scale and cost needed for billions of chips a year is still a genuinely hard engineering problem, and Chinese companies haven't fully solved the cost curve yet. There's also serious competition. Japan's Orbre has developed its own mass production technique for diamond wafers and is working toward 4-inch substrates while partnering with global materials giant Anglo American. This is not a race China has already won. It's a race China has a serious structural head start in. So why does this matter even before it's fully scaled? Because of exactly the pattern we keep seeing play out in China's chip strategy. Export controls choked off advanced GPUs. China responded by building its own AI chips and its own supercomputers using completely different architectures. Lithography machines got restricted. China started exploring manufacturing routes that don't need them at all. And now, while the entire world has been laser-focused on transistors, nodes, and GPU bands, China quietly secured a dominant position in the one material that might decide whether next-generation AI chips can even run at full power without melting themselves. Nvidia's entire roadmap, every future chip generation, every performance promise assumes cooling solutions will keep up with rising power demands. If the best cooling technology on the planet runs primarily through Chinese-controlled supply chains, that's not a footnote. That's leverage sitting quietly underneath an industry that didn't even know it needed to look there. Here's my honest take. I don't think this is China's Nvidia killer moment, and anyone telling you that is overselling it. Diamond cooling doesn't replace the chip, the GPU, or the software stack Nvidia has spent a decade building, but I do think this is a genuine inflection point because it proves something uncomfortable for the West. The next constraint on AI computing power might not be how small you can make a transistor, it might be how well you can keep that transistor from cooking itself alive. And in that specific race, China isn't playing catch-up, it's already holding most of the cards. This is the same story we keep telling on this channel, just wearing a different disguise. A wall goes up somewhere in the chip supply chain, and instead of stopping, China finds the layer nobody was defending and quietly takes it over. First it was packaging substrates, then it was domestic GPUs. Now it's the thermal layer keeping the whole system from overheating. Each time the lesson is the same. Restrictions don't close gaps, they just tell you where to look for the next one. So here's my question for you, and I genuinely want your honest take in the comments. If China ends up controlling the cooling technology that every future AI chip depends on Nvidia's, AMD's, everyone's, does that matter as much as controlling the chip itself? Or is this just another overhyped headline that fades out in a year? Tell me where you land, and if you've got a different read on this, argue it in the replies. I want to see this debate get heated. If you want to keep seeing exactly where China's next move is coming from before anyone else is covering it, subscribe to Iron Circuit and turn on notifications, and drop a comment letting me know what topic you want broken down next. We're just getting started here, and the next one is going to be even bigger. I'll see you in the next video. And before you think this is about jewelry, stay with me, because what China just did with synthetic diamond has nothing to do with engagement rings. It has everything to do with who gets to build the most powerful AI systems in the world for the next 20 years. And here is the honest truth that the headline version of this story is not telling you China already controls most of the world's supply of this material, and they just put it on an export restriction list. By the end of this video, you will understand exactly why Nvidia has a heat problem it cannot solve alone, what China's diamond breakthrough actually does inside a chip, and what this means for the AI race going forward. But before we go any further, if this is your first time on Iron Circuit, this channel covers the layer underneath the headline, the material, the supply chain, the strategic move the mainstream media missed. If that sounds like something you want more of, hit subscribe right now and drop a comment below telling me, did you already know diamond was becoming a chip material, or is this completely new to you? I read every single comment, and your answer will actually shape what we cover next.